Wow, we got to the end of this unit already. Okay, wow, that's pretty fast. So let's review 33 to 38. So 33, we started with solve each equation by completing the square. So what I want is that those that have letters on the left side and those that don't to the right side. So this minus 98, I'm gonna move it to this right side as a plus 98. So I have m squared plus 4m. Let me leave a space equals 96, right? Negative 2 plus 98 is 96. Then I think of my first number has to be a 1, which is good. If it wasn't, divide everything by that number. And then I see the second number is a positive 4, and I think the half of positive 4 is positive 2. I'm even going to write it down because I'm going to use it. Now, positive 2 squared, so multiply positive 2 times positive 2 is 4. So let me add 4 to each side. I'm completing the square. And we call it completing the square because on the left side, if I was to factor that, m squared plus 4m plus 4 is m plus 2 all squared equals 100. Now, to get rid of the squared, to get rid of the exponent, let me do the square root on each side. So that's going to give me m plus 2. I don't have an exponent anymore, just m plus 2 equals positive or negative 10, right? The square root of 100, positive or negative 10. So that means that m, let me move this positive 2 over. Don't forget to switch the sign. So negative 2 plus or minus 10. All right, well, let me find the actual solutions. Negative 2 plus 10 is 8. Negative 2 minus 10 is negative 12. So that was by completing the square. Now, question number 35, it says find the discriminant of each quadratic equation, then state the number and type of solutions. Okay, so first of all, it has to equal to 0 on the right side. So this minus 6, let me move it as a plus 6. So I have negative 6k squared minus k. I'll even write a plus 0 is equal to 0. Because I need to know an a value. My a is negative 6. I need to know a b value, which is negative 1. And I need to know my c value, which is 0. And I know the discriminant. We talked about this before. B squared minus 4 times a times c. So I'm going to go negative 1 all squared minus 4 times a negative 6 times 0. All right, so negative 1 squared is just 1, right? Negative 1 times negative 1 minus, interesting here it is, 4 times a negative 6 times 0 is 0. So my discriminant is 1. Okay, remember it says find the discriminant of each quadratic equation. So if I ask you find the discriminant is 1. Now, if I ask you state the numbered and type of solutions, because my discriminant is positive, it will be 2 real solutions. So if I ask you for the discriminant, it's just positive 1. If I'd ask you for the number and type of solutions, 2 real solutions. We talked about this before, so you should know those. Now, 35, solve each equation with the quadratic formula. All right, so I need to have everything on the left side. Let me rewrite this as 6x squared plus 11x minus 121 is equal to 0. Notice I moved this and this to the left, so they switch signs. I wanted my letters to go down when it comes to exponents, so I rearranged things. So I have that my A is 6, my B is 11, and my C is a negative 121. Okay. And I'm going to do my discriminant. That's where I always start when I do my quadratic formula. So let me remember the discriminant, b squared minus 4 times a times c. So 11 squared minus 4 times 6 times a negative 121. Now use a calculator if necessary. 11 squared, it's 121. Now this sign with this negative with this negative become a plus sign. Now 4 times 6 times 121 is 2,904. My discriminant is 3,025. So I expect two real solutions. But as a matter of fact, let me do the square root of 3,025 and I get 55. Okay, so that's not that bad. So let me remember the formula, the quadratic formula. A bad boy went to so-called radical party because the boy was being square. He lost a chance with 4 awesome chicks and everything was over at 2 a.m. I just did the square root. So let me see. So negative b. So let me write this as a negative 11 plus or minus 55. I'm not going to do the whole thing again. 2 times a, that's 12. Okay. So one of my fractions, so that's going to be my two solutions. For one of them, let me use the positive sign. So I have negative 11 plus 55 over 12. For my other solutions, I'm going to have negative 11 minus 55 over 12. Notice how I have one with a plus, the other one with a minus. Okay, negative 11 plus 55 is 44. So I have 44 over 12. Simplify it if possible. Let me divide each by 4. So it gives me 11 over 3. Okay. My second solution. Negative 11 minus 55 is a negative 66 over 12. Let me divide each by 6. Okay. Let me simplify my fraction. Let me divide each by 6. So I'm going to have a negative 11 over 2. Not bad. Now here, we're going to find all roots. Here, I want us to practice a few sections that we did. Let me find my possible rational roots. My factors of my first number is just the 1. My factors of the last number is just the 1. So I'm going to say my possible rational roots are positive or negative 1. 1 over 1, which is just positive or negative 1. Okay. Let me check one of them. Let me try positive 1. So I'm going to say, let's check positive 1. Let me write my numbers, my coefficients. I have a 1, a positive, a negative 1, a positive 1, a negative 1, and I hope my remainder is 0. Okay, so let's see if that works. If positive 1 doesn't work, then I'm going to try negative 1. Okay, so I bring down the first number, multiply by 1. Bring those, combine those, 0. Multiply by 1. Combine those. Multiply by 1. Combine those. Okay, cool. So yeah, 1 did work. One of my roots did work. Now I have x squared plus 0x minus 1, no, plus 1, and this is equal to 0. Okay. Couple of things I can do. I could write this as x squared plus 0x plus 1 is equal to 0. Use quadratic formula. And, your a squared, your a, b, c, all that. Or you could try factoring. I'm going to complete the square. Let me just go here. X squared is equal to negative 1. So that means that x is equal to positive or negative Square root of negative 1. The square root of negative 1, isn't that I? So I'm going to say my x is equal to positive or negative I. So my roots, one of them was 1. Remember, that's the one I tried first. It worked. Positive I, negative I. The way I know how many possible roots I have, that's the biggest exponent. Okay, that was not bad. Here, final roots, one root has been given. Okay, cool. So one of them has been given. So let's say this is 5, 1, a negative 1, a negative 18, a negative 2, and a negative 40. Because it says it's a root, my remainder here is 0. So let me bring this number down, multiply by the root, combine these, multiply by the root, combine those, times 5, negative 2 plus 10 is 8, times 5, cool. So one of my roots was 5, so that worked. So I have x to the third plus 4x to the second plus 2x plus 8. I cannot use quadratic formula because it has to be x to the second. I'm gonna say my possible roots, my exponents on the beginning are 1. My factors of 8 are 1 times 8, 2 times 4. So my possible roots are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And I'm going to start trying, positive 1, negative 1, positive 2, negative 2, positive 4, negative 4, positive 8, negative 8. Right? The one that works is the one that gives me the remainder of 0. Don't want to waste our time trying and getting them wrong. I'm going to try negative 4. Right? You guys might be like, why negative 4? Because I know the answer. That's why I'm trying negative 4. If I try positive or negative 1, positive or negative 2, positive or negative 8, trust me, it's not going to work. Your remainder is not 0. Now, you don't know the answer, so you will have to try a few. Like I said, I'm going to try negative 4. So my coefficients are 1, 4, 2, and 8. And I'm saying my remainder will be 0, right? Again, if my remainder is not 0, it doesn't work. So bring the first number down. Multiply by negative 4. Combine them. Multiply by negative 4. Then combine this. Multiply by negative 4. Boom. See how negative 4 worked. Any other would not work. As a matter of fact, let me show you what I mean that they don't work. What if I try positive 1? So 1, 4, 2, 8. And I'm saying, oops, that my remainder is 0. Let's see. 1, this is 5 times 1. This is 7. 7 times 1, right? 8 plus 7 is not 0. So that's why I said it doesn't work. The only one that works is negative 4. So now I have x squared plus 0x plus 2. And I know this has to equal to 0. Tried quadratic formula, try whatever you want. I'm just going to do x squared is equal to negative 2. So x is equal to the positive or negative square root of negative 2. So x equals positive or negative I radical 2. Okay, so all my roots are going to be 5, because remember that one worked. Negative 4, because remember that one worked. Positive I radical 2, and then negative I radical 2. That's it. Okay, now the last one, Descartes, find all zeros for each function. I'm just gonna ask you to list the possible real zeros or the possible imaginary zeros. So I'm gonna do f of x, and I'm just gonna look at the sign. For x to the third, for x to the fifth, x to the second, x to the one, and then a negative 96. I was just looking at the signs. And then I noticed that the signs change once. Okay, so it changed once. Now let me look at f of negative x. So let me write this as negative x to the third plus 5 times negative x to the second plus 8 to the negative x minus 96. So this is negative x to the third plus 5x squared. Remember, when my exponent is even, basically becomes a positive x. When my exponent is odd, I do keep the negative. So minus 8x minus 96. So the signs are negative, positive, negative, negative. So let me see how many times it changed from negative to positive, from positive to negative, and it remained negative. So possible real solutions, the maximum is 3 because I added 1 plus 2. So maximum is 3 or 1. So these are the possible real zeros. If I ask you for the possible imaginary zeros, the highest is 2 because I subtracted my highest exponent minus the smallest real. So 2 or 0. So if I ask you for imaginary, it's 2 or 0. If I ask you for possible real zeros, it's 3 or 1. We can find them, but I just want to review Descartes' formula.